Getting acquainted with writing proofs. We did an algebraic proof a few moments ago. Now we're going to do a couple of geometric proofs. And I'm going to use a modified two-column proof in that I'm going to have the statements and then I'm going to put the reasons in parentheses. But we're asked to write a two-column proof to verify conjectures. Now we see a couple of objects here, a couple of angles, angle A and angle B. And just on the face of the object, I don't know a whole lot about it, but we're going to get into it, and we're going to be given some information from which we can then write our proof. So it says if, and now here's our given, if angle A is congruent to angle B, and the measure of angle A equals 37, that's our hypothesis of our conditional statement. Then, coming to our conclusion that we're trying to prove, then the measure of angle B equals 37. Now, you might look at that and think about that for a moment and say, well, sure, that's got to be true. But we got to do the why, and we got to do it step by step, and that's the essence of writing a proof. So, we're going to give our statements and reasons, and again, rather than actually have two columns, I'm putting the reasons in parentheses. So, first up, we always state our given, and that is that angle A is congruent to angle B, and we got two given statements, and the measure of angle A equals 37. Now, let's begin with our proof. You notice here that we took the first part of this, the angle A is congruent to angle B, and we now have set that the measure of angle A equals the measure of angle B. Now, anytime you see yourself go from a congruency statement to an equality, or from an equality to a congruency statement, either way, then it's always going to be the definition of congruency. And this time, since we're dealing with angles, it's the definition of congruent angles. In other words, congruent angles are equal to each other, and we know that. But we're just having to break this down step by step. Now next, 37 equals the measure of angle B. And that's really substitution. Think about it. If the measure of angle A equals the measure of angle B, and we're told in our given that the measure of angle A is 37, all we're doing is substituting 37 for the measure of angle A, and that is just substitution. Now, what is it we're trying to prove? We're trying to prove that the measure of angle B equals 37. Well, this is pretty close, isn't it? 37 equals the measure of angle B. But if we flip that around using the symmetric property, then we have got it in the form that we're looking for, that the measure of angle B equals 37, and that's using the symmetric property. Remember, if A equals B, then B equals A. All right, so we're good to go on. So let's now look at this second proof, geometric proof. Now here I got two line segments. I got CD and I got EF. And here I'm told that the measure of CD is 3y minus 9, and the measure of EF is 15. So I got a little bit more information than I did on the angles, but let's go through our two-column proof. And here we've got our statement. If segment CD is congruent to segment EF, that's our hypothesis, then our conclusion, y is going to equal 8. And again, we could look at those and we set 3y minus 9 equals 15, and we solve it, and it'll probably come out to 8. In fact, I know it will. But again, we're writing a proof. We're having to go step by step. And that's what makes it tedious, and that's why a lot of people don't necessarily care for proofs, although some really do. And this is teaching us a logical sequence of thinking using deductive reasoning. That's why we do this. So let's see, we're going to go with our statements and reasons, and we start off again with our given. And what was our given? If segment CD is congruent to EF. That's our given. That's our hypothesis. We're trying to prove y equals 8. Now, notice again, I went from a congruency statement to an equality statement so that CD is equal to EF. And that's the definition of congruent. And again, this time we're talking about segments. Last time we talked about angles. This is the definition of congruent segments. Now, 3y minus 9 equals 15. And what we did there is substitute. We're told right here that CD is equal to 3y minus 9 and EF is equal to 15. And we just substituted that in for CD and EF. Now, we add 9 to both sides of the equation, and we end up with 3y equals 24. And what do? We added. We used the addition property. And what else are we getting ready to do? We're getting ready to divide, aren't we? We're getting ready to divide both sides of the equation by 3. And when we do, y equals 8. We use the division property. And what was it that we set out to prove? That y equals 8. And shazam, we have done so using a 2-column proof on these line segments and previously the angles. Oh, don't you just love proofs? Maybe not.